Hey Internet, today's topic is heat transfer. This is a heat sink question. We have an extruded aluminium heat sink, 85 by 52 millimeters. It's got a K of 180 watts by meter degree C. It's got a 3 millimeter thick base. It's got three 35 by 2 millimeter thick fins. See the Solidworks below. We have a base temperature of 55 degrees. We got a heat coefficient of 22 watts per meter squared degree C and surrounding temperature of 18 degrees C. Find the following: efficiency of the fins, heat transfer from the fins and base, ignore the underneath and the sides of the base, overall effectiveness of the fin. So I typed out all the variables and I have got a brief explanation of what everything is. And I've worked out what some of these things are to save time. So everything is given. It is just a plug and play question. I'm going to assume that you guys are going to practice this question and check my math because I'm human and I make mistakes. So it's just a matter of explaining the equation and then you can plug and play yourself. Okay, so find the efficiency of the fins. So this is the formula to find the efficiency of the fin. This is hypertangent. You can find that on your calculator. M is a unitless coefficient. LC is the cross-sectional length. So to find M, it's just the square root of H times perimeter divided by K times cross-sectional area. And then you'll get this number, plug and play. Same, just follow this formula, L plus cross-sectional area divided by perimeter. And then you should get this percentage, 94.1% efficiency. Okay. Find the heat transfer from the fins and the base, ignore underneath and the sides. So you got this formula, Q dot total fin is equal to H times area of unfin times base temperature minus surrounding temperature plus the number of fins times the efficiency of the fin, which you found earlier, times the area of the fin times base temperature minus surrounding temperature. And for the area of the fin, you can use this one, which is 2 times the width times the cross-sectional length, which can be found in your heat transfer textbook. Again, plug and play, and then you should have a total of 17.37 watts. Okay, find the overall effectiveness of the fins. So this is the effectiveness fins formula. It's the total heat transfer from the fin divided by the total heat transfer of no fins. So basically this is the base with the fins, and then this is just the base itself. So we already found with fins, which is 17.37 watts, and then you just have to find the no fin heat transfer. So for this formula, it's just H times area no fins times base minus surrounding temperatures. Plug and play. So you should find your heat transfer no fin to be 3.597 watts. So it's just 17.37 watts divided by 3.597, which should give you 4.8278 or 4.83 effectiveness. Okay, thanks for watching. Hope you had a great day. Be sure to like, subscribe, share with your friends, ring the bell, comment if I made any mistakes. Also turn on all notifications. Also, do you guys prefer the Microsoft Dark mode with the gray background, or would you want me to go back to the light mode? For me, I just find that it's easier on the eyes, so comment below if you like the light mode or you prefer this dark mode. Okay, until next time, see ya.